Hello everyone, how you guys doing? I hope you're all doing amazing. Welcome to another video. Now today we are solving the problem Roman to integer. This particular problem is a LeetCode easy problem and I'm pretty sure most of you will be able to solve it just by looking at it for some time. But I still wanted to make a video on it just so that we can continue on our series. And we're going to follow the same process we have been following for all the other problems because if you solve the easy problems as the hard ones slowly becomes easy for you. At least that's how the saying goes somehow. I don't really remember the exact saying. But yeah, I'm already wasting time by saying all of this. We shouldn't take too much time into solving this problem. So just to read through the problem once, as the name suggests, we are supposed to convert Roman numbers to integer numbers. And here we are given the different symbols that are going to use in Roman numbers and what are the values of them. Now here they have defined the rules of Roman numbers. So I hope most of you must be aware of them and have read it in like 5th or 6th standard. And if you are in 5th or 6th standard, wow, you're really learning DSA now this early? The competition is too high. You have the numbers. If you have smaller numbers ahead of them, you just add them. If you have a smaller number behind a number, then most probably you are subtracting it. As you can see here, if you have to write 4, you don't want to write it like this. You actually write it like 5 minus 1. So the number behind of your bigger number is always going to be subtracted if it is a smaller number. So we can see it here as well. So now one more thing to notice here is to go through one of the examples just to make sure the rules in your head are correct, because this is one of the problems I faced while solving the problem, that I didn't remember all the rules that applies to Roman numbers, and that's why I made a mistake. But basically, if you go through some of the examples, you can see that 3 is represented like this, as we would expect. 1 1 1, all are added, it gives us 3. Then to represent 50, 58, we basically do a L and a V. This gives us 50 plus 5, so 55. And then we add all the small numbers ahead of it, so it gives us 58. Now, when we have to represent 1994, what we do is we take the value for 1000, which is M, and add it right here. Then we take the value for 100 and subtract it from the value we have for 1000 again to represent 900. So we are representing things one at a time. So to represent 1000, we just put M. Then to represent 900, we put CM, because C would be subtracted from M. And so the basic thing that I want you to notice here is that every value of subtracted if it is only one step behind of the value. So to get 900, we didn't do 500 plus 100 plus 100, because again we don't want to represent with more than 4 numbers. But instead what we did was we used a smaller number and subtracted it from our particular value, and that's how we are able to get 900. Similarly, we subtract 10 from 100, I think that's what it is. Yeah, that's how you get 90. And then finally you get 4. 4 we are already aware of. So we are almost doing it as we do with any kind of a decimal number or any number system, in that sense, where these are your different stages of a number system, and you are going through this number system to finally get to your answer. So if I go to the whiteboard now and I write down the first example, or the most complicated example, why to take the first example, we have the MCM XC 1 and V. So this should give us, I think, 9,999 or 94, sorry. So if I go here, I know that M represents 1000, so I already have 1000. Then I go to the next step. I see that my value is C, so it is something I'll keep in mind. So C is what I get. Then I get M, so I know that C is smaller than M, so they both will be representing 900, because 100 minus 1000. So that's how I get 900. And then I go to the next step. I see that my value is 10, and I stop there. I first check what is the next value, and I see that the next value is C. Then I say that X is minus 10 and then C is 100, so this should give us 90. And that's how we finally get to 4, which we already know from these two values. Now, what exactly are we doing here? The first thing you have to notice is that we are waiting for the next value to come before getting the value, to be sure if it is actually going to be negated or is it going to be added. Now, why do I say that? Let's take another example. Let's say we take the example of MCM XVI. Now, in this particular example, M still represents 1000. And as we just said, We wait for C and M and we see that this represents 900. So this is still okay. But this time X is not subtracted. And why is that? Because X represents 10 here, but the number that follows X is actually 5. So X is also going to be added and 5 is also going to be added. It's not going to be minus 5 here. It's in fact going to be 15. So this is going to give us 15 and finally I is going to give us 1. So this will give us 1916 as the final number. So basically to tell if a particular number is gonna be subtracted from your overall count that you're keeping or it's gonna be added to your overall count, you basically check if that number is smaller than the next number that is gonna follow it. That's how we are forming these Roman numbers. Now, there is one more way of thinking about this where instead of worrying about the smaller number and the bigger number, you can just say that only the cases with 4 and 9 is when you subtract a value. So when you want to represent something that follows with 4 or something that follows with 9. Now, what do I mean by something that follows with 4? That's just you add a bunch of zeros on it. So anything that follows with 4 or anything that follows with 9 is always gonna be represented in minus form. So whenever you are checking for a value, you can just check for these kind of pairs. There's always gonna be limited number of such pairs. So for example, you have CM, you have other numbers as such. So CM was one of the examples, and XC is one of the examples to represent 9. This is also to represent 9. To represent 4, you can have something like, uh, we have, what was the number for 50? I think it was D. So you can have XD, this is going to represent 40. So all of these pairs. So you have a standard number of pairs. You can maybe store them somewhere in your program, and that will allow you to be able to again calculate whatever are going to be your negative values. But simply speaking, what we are doing is we are just checking if the small other value is smaller or not. And if it is a smaller value as compared to the next value that it's going to follow it, we are subtracting that initial value. Otherwise, we are adding it. So let's try to do a dry run before coding again, just to make sure we understand the complete logic of what we are trying to code up. And then we'll go to the LeetCode platform and just try to get done with the solution. So let's just try to write this down again. MCM XCIV. And this time I'm gonna start very slowly by the logic that we have just understood. So we see M and let's keep a total count. So our total value till now is going to be 0 initially. The total is 0. Then we see M and we add 1000 to it because the value of M is 1000. And that's what we do. So this is the first step. Now we are on the second value and we see that there's a C here. Now what should I do? Well, if I don't have any information about the next number, I'll say that let's just add C. Maybe there is no other number. So I can just add 9. C is 100, right? So I can just add the value of C here, which is going to be plus 100. Now, when I see M following it, so when I go to the next iteration, I'll first check if this value is actually smaller than the previous value that we just saw. So if it is smaller, then it is perfectly fine. We can just keep adding the values and we don't have anything to worry about. But if this value is actually greater than the value that followed it, so everything should be in some sense in descending order if they want to be added. But if there is any pair that is smaller previously and then becomes a bigger number later, that means that the whole pair represents another number. So in this case, we want to add the 1000 that we just saw, the M value that we just see. But at the same time, we have to subtract the previous value. Now, we don't just want to subtract the previous value, we have to also remove the trace of it from the previous iteration where we added it. So we basically want to subtract 2 times the previous value. So basically, what we understand from this dry run is that whenever we want to keep account of whatever total integer value the Roman number that we are iterating is trying to represent, we just have to maintain the previous value, and every time we will check if the previous value is smaller than our current value or not. If it is smaller, at that point we want to subtract 2 times of that value from the current value that we are at. Otherwise, we want to keep adding the values as they come, as the Roman integers follow in a descending order. And if we are receiving a smaller value, I am pretty sure that it is there because it is going to be subtracted from a bigger value up ahead. So that is the whole idea. I hope it made sense. Now again, I went through this problem really fast. There was no intuition going on. There was no force answer in this particular solution. And the reason for that is that it is comparatively a simpler problem. And I just wanted to make this video as more of a guide or more of a thought process journey on how you can solve these problems quickly, where you can observe these patterns, or you can try to go through some examples and see that such cases exist where the previous value is smaller than the next value, and how can that help you. So I think the examples in this particular problem are really helpful, because if I didn't have the 1994 example, it would have been a little bit more complicated for me to come up with such an example and get to this solution. But we did have this example in this problem, so that's great. And now as we are back at the LeetCode console, let's just try to code this up. So as we first discussed, we want to iterate through the array, but before even doing that, we need to be able to store this mapping somewhere inside of our Go program. So to do that, I'm just going to write a map, which is going to be between a rune and an int, and let's just call it something. So let's just call it symbols, and I don't need to do let here. Some JavaScript leaking in from all the front end I've been working on recently. If you haven't watched the chess analysis project, please go and do. It's really fun. But okay, we have to create a map right now between a rune and a int, and we're gonna store inside our values. We have our map created. Oh my god, I just closed the tab accidentally, didn't I? Okay. Cool. So we are able to write down all the symbols. Now what we have to do is just maintain a total value, which is going to start at 0. And then we're going to keep adding and iterating as we go through it. Now again, to iterate through ruins in Golang, we're going to just write a simple for loop, which is going to start at 0. I is less than len ruins. So first of all, we'll have to initialize the ruin part. And to do that, I think the really simple way was to have the string as a list of ruin. And yeah, so this should be able to give me the string as a list of runes, and then I can just iterate through runes. And I don't think we can use len like this. I think it's a function I plus plus. And now inside of the loop, I want to check whatever character I'm at. So I will be at runes I. And in there, I want to check which mapping it belongs to. So the value, let's just call it values instead. That makes more sense intuitively. So values of ruinous, and we're going to say that this particular value is going to be added to my total. So total plus equal to values of I. But before doing that, we are going to also maintain a previous value, which is going to start at m, let's say, because it should be the greatest value that we have. The previous value, which is going to start at our 1000, let's say. What's the maximum number we can receive here? So the maximum number is 4000. Okay, so let's just keep it as 5000 just to be safe. Now, if the previous value, and let's do this before adding it in our totals. We can do it anywhere, it will still work the same, but let's just do it here. So if previous value is actually less than our current value, which is our values given as I, then in that case, we want to do total minus equal to 2 times previous value. And here, after adding in the value to our total, we also want to subtract it, which, or actually set the previous value. What am I even saying? We have already subtracted the value. So previous value is now going to be values ruin as I. That's the only thing we want to do. That's how we are maintaining the previous value each time the loop ends. And finally, we are checking if the previous value is less than the current value. At that point, we are going to subtract 2 times the previous value because we have already added it. So we want to also take that effect out of it. And that should be our answer. So we should be able to return total. Let's see how many syntax errors we cause because I have not used Go from a long time now and I must have forgotten a lot of syntax. Yeah, so ruin as n is not defined. No field or method len. I think it's not like this then. I think it is supposed to be a wrapper like Python. Let's just try this. Or maybe it's just dot length. I'm not really sure. Oh, okay. It was a wrapper. So cool. It is accepted. There's not as many compilation errors as I expected, which is great. I think I just remembered Go syntax somehow from all the amazing videos we have been watching. And if you could just watch the playlist, we can get a lot more subscribers and a bigger community. So do that. But okay, we have got the cases and it is working for all the three cases we had, the third one being the most complicated one and our example for the problem. So I think everything should be great, and let's just try to submit the solution and see if it works or not. Are you ready? Let's go. Submit. Drum rolls. Cool. So it works. It beats 100% in runtime, and in memory it beats 18.76%. Now I'm not really sure, is it because I'm storing the ruins like this or anything else, because I'm not storing anything else in the memory. So let's just go through the program once again to tell what's the memory complexity and the time complexity. So if you can't tell by yourself, we are only iterating through a single loop, so that time complexity is going to be whatever the length of our string is going to be. Now, in this case, the maximum length we are ever going to receive was 15. So it's almost a O of one solution where you can't go more than 15 iters inside of your array. And the memory complexity in this case, we have a constant space. We are storing these 6 or 7 keys. I don't really want to count them right now. And we are also storing the total value, which is again O of one memory. So it's almost O of one time because the length is 15, the maximum length is 15. But in the worst case scenario, let's just consider the time complexity as O of n because we are actually iterating through the length, and our memory complexity is just O of 1 because we are not storing anything as such inside of our memory except the total value, which is our return. So cool. So it is working, it is accepted, and that was the video. If you really enjoyed it, please leave a like and subscribe. Really need those right now, and see you next time. Bye bye.